Alright, so this is part 2 of the software-defined networking. And so what is happening is that people are giving up on standards bodies. Basically, standards bodies are just too slow. You develop a standard for 4 or 5 years, then you implement it, you do the interoperability, and by the time the technology is out of date. So they are going for direct implementation. Forget the whole standardization. Just implement something, and if it works, that's the standard. And the reason and the way to make that a standard is to make it open source, so everybody can use it, everybody can change it, so nobody can complain that this is proprietary. So every company, starting from Facebook to you name it, Google, to everybody else, they are throwing their software in public and saying use this, and this is the standard. Anyway, Linux is a well-known open source software for a long time, so it's not a news, but I'm going to start with Linux here. So there is a version of Linux which is called Open Network Linux, ONL. Now you have seen many versions of Linux, Debian, this and that, Ubuntu, and so on and so forth. So there are many of those, but there is one called ONL. Okay? And don't confuse ONL with Open Networking Lab. This is ONL is Open Network Linux. And this is a Linux distribution for bare metal switches. Now I will describe the bare metal switches in the next slide. But there is something called Open Compute Project. So the software is one thing which takes time. Hardware takes even more money and time. So they said, Facebook came up with this idea that why don't we just everybody use the same hardware kind of thing, standard hardware, and rather than standardize anything, we just basically come up with some small set of things that is standard. And one of the things which is happening in the industry is what we call disaggregation. Disaggregation means you do not have to buy both the software and hardware from the same vendor. It's like this: you don't buy the laptop and the operating system. Actually, you buy both from the same vendor, but you don't have to. I mean, you can buy the laptop from Dell and buy the operating system Linux or Windows or Mac or whatever, right? So that is called disaggregation, disaggregating the hardware from the software. So that is same thing is happening in networking. Previously, you used to buy, and actually even now today, we buy a Cisco router, or you name the company. It doesn't have to be Cisco. You name any other company, Juniper, or any other company. You buy the router, and it comes with hardware and software, and everything works, and that is nice, right? But people are thinking, now this is again a thinking, not a fact, that if we had a freedom of choosing the hardware and the software, the life would be much easier and cheaper. Okay? So that is what is being tried, and that is what we have been discussing for the last 3-4 years in terms of SDN, software-defined networking. So software-defined networking didn't come out to be a programming issue where you had the open flow protocol. It came out that really the issue is disaggregation. So SDN has become disaggregation. SDN is equal to disaggregation, which means that you can take any hardware, well, not really any, and we'll talk about the hardware, and you take any software, and not even any, but we'll talk about that. So basically you can combine the two. So you have multiple choices of software, multiple choices of hardware, and you can combine. That is called disaggregation. So for the software, there are many choices, and ONL is one of them. So ONL is not the only thing. Okay? There are many other systems. At the extreme, you could just go and get what is called iOS, which is the operating system that Cisco uses. Cisco's interconnect operating system, or whatever that is, iOS. Juniper has similarly Juno OS, which is Juniper's operating system. So every vendor has their operating system, which what operating system does is it provides facilities on which you can run applications. And the applications are DHCP, BGP, OSPF. All these protocols are the applications for these operating systems. So they write the application, they put the operating system, they design the hardware, and everything works from beginning to the end, right? But now people are saying, let's disaggregate. All right? So we'll have a different operating system. And one of the operating system, which is I'm going to discuss today, is ONL. It's part of the Open Compute Project. So what is Open Compute Project? Basically, this is the thing from the Facebook, and you can go to OCP. All the URLs are there in the bottom. You can go to the OCP website and see that they are just standardizing all kinds of hardware and software and pieces and applications for computing, so that everybody and everything is open. That's the keyword, is open. Compute means it's open. Basically, open means open source. Okay, so you have the source code in front of you. You can change it, you can modify it, you can use it any way you want. Now, I could go on and give you a lecture against all this. I'm not going to do that right now, because this will naturally happen in future. When something happens, a wave comes in, people go that direction, they find, oh, no, there is a problem with this direction, and they move. And so right now the wave is in the direction of totally open. And so it's part of the Open Compute project. Okay, and Open Compute project started with the hardware, and now they are getting into the software. And it supports multiple switch fabric APIs. Now, what that means is that you can buy a switch from many of the vendors, which are coming up in a list somewhere. You buy this switch, and then you run ONL on it, Open Linux on it, right? And then you get all these pieces of software, routing applications. We call them routing applications, but they're really routing protocols. Right? Routing protocols, and you run them on Linux, and you got a router. Make sense? Everything? Okay, all right. So the protocol that it supports for the API towards the switch. So now there is an operating system, and there is a switch fabric, which is the hardware. So between them, it supports OFDPA. OFDPA is Open Flow Data Plane Abstraction. All right. Now, so this is here's the game that is being played. Everything is open here, right? OFDPA is open software, but it is designed for Broadcom chips by Broadcom. If you are using Broadcom chips in your hardware, then you get OFDPA. And so that's the kind of question comes in my mind. Open does not mean public. Open simply means it could be proprietary like this, where it runs only on their hardware. It's just open. It's just open in the sense that you have the source code. And so open data plane abstraction, open flow data plane abstractions for Broadcom chips. Open NSL, open network switch layer for Broadcom switches. So there is some kind of API that they define, again Broadcom. SAI, switch abstraction interface, and this is the one which doesn't have a vendor name attached to it. So this is gaining more momentum. I heard more SAI at that conference than other of these terms. Okay, so there are many interfaces which are being designed between the operating system and the hardware. And so on the top, on this, right? Now, this is the router. Now, the router also has forwarding agents. Forwarding agents are those, okay, let me say this. Forwarding agents are actually next slide has that, but let me say. So on the top, there are routing protocols. So this is Linux is designed so it's compatible with many routing protocols. Actually, the routing protocols are designed so that they're compatible with Linux, just to be sure. I mean, they're not compatible with Windows, for example. So the routing protocols are compatible with Linux, and on the bottom side, many forwarding agents are compatible with this. So the whole thing will work. So bare metal switches. So where do you get these switches? Okay. Again, every vendor has a switch which is different. All right. And they have tested Open Network Linux with hardware from these companies whose name are listed, and I can't remember, so I don't expect you will remember. But the idea is that every vendor takes their switch to ONL and Open Linux Forum, whatever the URL is. So they take it to that group and they check it out. They say, "Yep, this is compatible with Linux, and we can use it on Linux, or we can use Linux on it." All right. So there are many vendors who are making the hardware. All right. So Open Network Linux is supported by hardware from these vendors. And if you go to the website, there's a whole big list. From each vendor, there are tens of switches of different speeds, different port numbers, different this and that. In general, the design of the chip, and this is a standard switch design, is that there is a very high speed, and I've shown that by thick lines, high speed ASIC, which does the switching between the ports, which are very high speed. But then there is a slow speed part where you do the management and stuff, changing, talking, whatever you want to do. So there is a CPU, which has a memory, there is a flash, there is a mass storage, permanent storage, and there is a serial console. This is where you can just connect your console, your thing, and then you can give the command, or you have Ethernet port for management. This is a slow speed port. This is not a 100 gigabit port. You just have to connect on the internet to connect to it. So this is a standard bare metal switch. All right. However, depending upon who you buy it from, the CPU would be different, the ASIC would be different, and so on and so forth. And all these ports would be different, right? And therefore, you have to be sure that whatever bare metal switch you buy is compatible with whatever software you're going to run on it, which in this case is Linux, right? All right. So, so this is a bare metal switch. All right. Now, what do you run on the top of the Linux? Okay. On the top of Linux, you run many suites which are open source again, and actually they are not new because they have been around for a long time. Open source, and one of the popular ones is Quagga. Quagga was a very popular open source routing software suite, which has most of the things that you will want to do, like OSPF, RIP, BGP. And from now on, I will not really list these protocols because all of them have the same, similar things. One or two plus minus, don't worry about it, right? But when I say open software forwarding agents, that simply means that this is OSPF, BGP, RIP, and DHCP, IMC, ICMP, whatever you need in a router. All those protocols are called routing protocol suite, right? And there are many different packages or different groups which are making this, and the Quagga was the old one, right? Quagga was the old one, and then Bird was an old one. So if you go back to my previous slide, which you don't have to, but basically Quagga and Bird were there, but now there is a bigger list, so I gave up on the old list. So Quagga and Bird. Now Bird actually came from a particular university as a student project. The students said, okay, let us write a routing software, and they wrote the project, and then government gave them some more funding, and then it became a worldwide thing. You want a free router, you just get the software from there, get your computer and put the Linux on it, and you got a router, right? And so I think that is probably on its way out, because given that these other things which are supported by multi-billion-dollar companies, this will not survive. But right now, FR routing looks like on the front. Okay, so this is a fork of Quagga. Spelling of the Quagga on the second time is wrong. So Quagga, Quuagga, and then so basically it's a fork, and you know what a fork means because you have seen so many forks of Linux. So it's just a version of that, and then you just take it and then you start developing it with totally independently, right? So it's a fork. And Linux routing protocol suite, including BGP, ISR, and it goes on list. The name free FR routing, I'm not sure what it stands for, but the closest I could come to is free range routing, and I don't know why. Okay, so they don't spell it out. Even on the project website, they don't spell it out what it stands for, but somewhere people said free range routing, so I have put a question mark there. Bird. Now Bird, I don't know what B stands for, but IRD is Internet Routing Daemon. Okay, And Internet Routing Daemon developed at Charles University Prague, and it is supported and it is active and people use it, right? Then the Facebook has open sourced its own open switching system, FBOSS, and FBOSS is they are pushing FBOSS. Microsoft is pushing Azure Sonic software for open network in the cloud, open networking in the cloud. So the reason you need Sonic is if you are going to do all of this, you're not going to do it in your lab, you're going to do it in a cloud. You're going to take a VM from somebody and then put your Linux and you put your software protocol suite. So if you're going to do it on Azure, then Sonic is there, right? If you want to do Open Linux, if you want to do Quagga, you can get Quagga too, but then you have to somehow get Quagga into Azure and put it on it and all that. Sonic is developed by Microsoft, and they are pushing theirs. Google is pushing GNAS, and believe it or not, I could find no information on GNAS. So maybe it is just available on Google Cloud, and maybe the information is still coming out. So you see what is happening in software-defined networking. Originally it started from OpenFlow, then it became programmability. Now it is not programmability, it is disaggregation. Freedom of choice, that's what it is. You can choose the hardware, you can choose the operating system, you can choose the protocol layer. So now you need one more little piece, it turns out, and that is called ONI, Open Network Install Environment. And Open Network Install Environment is something, and it says install environment. So when you are installing, only that time you need it. Okay, and first time, you bring your hardware from somewhere, and you bring your software on a disk, and you bring your applications on a disk. Now you want to put all that together, so you need this little piece of software, which is called ONI. ONI stands for Open Network Install Environment, and it allows many operating systems to run on the hardware. And I don't know why you need all this, but anyway, here is the picture. So you take this switch, and the switch will come with its own boot loader. And let's say you need many pieces of software. First piece of software doesn't know anything except that it knows the hardware, and it says, okay, I am the hardware ready, now tell me, where should I load the boot image from? Right? So that bootloader is very much like the firmware that comes on your computer. When you boot your computer, the firmware comes up, and it knows all about the hardware. And so that is the bootloader, comes from the hardware vendor. And then there is this little piece, ONI, which is standard across the industry, in some sense. And the ONI, it will be supplied by the hardware vendor, but it is a open thing. So it says from hardware vendor, but basically what it is it will, now it is more intelligent, little bit more really software centric in some sense. So it will then, it can ask you, in fact, or it can somehow find out by some method that what operating system you want to read and from where. So now this becomes more like firmware, is where it could say, well, it will go and check USB. Is there a USB there? Is there an operating system on it? Is there a hard disk? Is there an operating system on it? Is there a network? Is there an operating system on it? So from somewhere it will locate the operating system. Right? And then it will, then that is not still the operating system. That is the operating system installer. So that is a NAS installer. On the top of ONI, you see Network Operating System Installer. And that will bring the operating system. Now operating system is big, the installer is small. It's like when you download any software nowadays, like if you download even some browsers, they don't download the whole thing. All you get is the installer. Installer is only 450 kilobyte, very small. And then it goes and downloads 55 megabyte of the software. Right? You understand what is installer, right? So the installer is what ONI installs. Now once the installer is installed, then the operating system comes back from a disk, big amount. What happened?
I'm just muting this one so that.
Okay. Yeah. So all this is done very first time. So you understand where ONI fits in. ONI is between the hardware and the software, right? And it is one-time deal. Next time, everybody knows everybody. You have introduced the hardware to the software, and if you don't want to change anything, the hardware will find the software.
But of course, if you need to change.
Yeah, if you need to change, then you can go back. If you need to change, you can go back to ONI. But if you don't need to change anything, then subsequent boots straight bootloader to network operating system. I mean, you don't run installer every day after the browser, for example. It's there, and the operating system knows what browser you want to use, and then it just uses that browser. Okay, so this is where ONI fits in. Now, I have also put in detail as to what these different things do. So the bootloader simply loads ONI from flash. Actually, this is the first time. Next time it loads NOS from whatever, right? And then ONI is a thin Linux OS. So ONI itself is a Linux. Okay, now you see Linux twice. ONI itself is a Linux. It's a thin Linux OS operating system. Configures the management Ethernet interface. Management Ethernet interface. So here is, if you go back to the previous picture, this is the management Ethernet interface. Alright, so ONI will configure this. So now this has networking capability. So it can read the image if needed, or the installer from the network if needed. Right? So configures the management interface, locates and executes the NAS installer, and locates the next thing. The next thing is an executable, is a Linux executable which could be on a USB or network, and installs the NAS in mass storage. So now the operating system itself is big, and therefore it has to stay on your disk, and so that is what the installer does. Once the operating system is installed on your disk, you don't need to install it every day. It's there. And what does the operating system do? It can configure the switching ASIC, which is this thing, switching ASIC, and it runs the protocol stacks, all the protocols that we talked about, and it provides CLI. And you understand what CLI is, command language interface. Right? That is where you just type some DOS-like commands.
So you can write applications for
Yeah, applications for this. All right. So this is what is happening in terms of SDN. Any question about SDN? Now I'm going to take a total different turn on the next slide, and I think we are going to almost finish on SDN. Any questions?
Actually, I have about the Open Network Linux. It's not so clear in my mind. Yeah. This is a kind of Linux that I can install it on the computer, or I would install it like on the switch, like you said.
All right. So Open Linux, Network Linux, just like any operating system, is not tied to hardware.
Okay.
All right. So you should be able to download, theoretically speaking, you should be able to download it on your laptop. All right. However, to run on your laptop, you need these glues in between, you see, so that it will understand what is what, right? And so you will need some kind of things, and I think here's the thing, these bare metal, the only thing that your laptop doesn't have is this high speed switching ASIC and 10 gigabit ports. All right. But if you want to stay with 10 megabit ports or 1 gigabit ports, you can put few more by using some USB cards. You can have more than one port, and you got a router. In fact, that's what we do in our lab. We have some desktops, old desktops that we had no use for, and they cannot do any computing anymore. So we put 6 Ethernet cards in them, and we make them switch.
Good. Now I understand. Okay. Thank you.
Right?
Yes.
So we can probably try this ONI and Open Network Linux and all that. We don't use Open Network Linux, but the thing is, we probably use Linux, or I don't know, we might even use Windows, who knows. So because it's not very high speed. But if you want to do high speed, then you need this special hardware. Alright, so next piece of software which totally out of place, I had to put it somewhere, is Mininet. Now Mininet is not, has nothing to do with really SDN. It has to do with networking, and is every time we started doing anything research in networking, we found that we need Mininet. Okay? In particular, when we started working with SDN, we needed Mininet, and so I put that in this module. Okay? And what is Mininet? Mininet is a simulation software. It's simply a network simulator. So network simulator, there is NS3, NS2, and OmniNet, and OmniNet Plus, and there are many other OmniNet Plus Plus, OpNet, and so on and so forth. There are many simulators, but Mininet is let's see. I'm not sure whether it is open source or not, but it is openly available. So you can download it simply and use it. And believe it or not, it was written by one of the WashU students who went to Stanford, and he wrote it from there. So it doesn't. WashU doesn't get a credit, but I know the student. We know the student. He was here. So Mininet is a open source network emulation environment. Emulation environment. So using on your own laptop, if you download Mininet, you can now simulate a network with 5 switches connected to a router, 3 hosts, 1 host running this, another host running that, third host running that. Like it's like open networking lab on your laptop. Okay, so if you do research in networking, you will probably end up using Mininet, and we do have a lab on Mininet as part of this course, and I don't know where it is coming and why it is not coming yet, but if not, maybe next time it will be there. So there will be a lab where you just have to download Mininet and just do some simple things. Install an operating system, ping a computer to the next computer, and everything is in your laptop. Okay, it's very easy. So Mininet is widely used open source network emulation environment, can simulate a number of end hosts, switches, routers, links on a Linux, used for rapid prototyping of software defined networks. If you want to play with all these different open source stuffs, you can take the real software and install it on a host. This is really interesting, and you can do real things. Built-in Open vSwitch and OpenFlow capability. So Open vSwitch is built in, and command line launcher and Python API for creating networks of varying sizes. For example, you say MN, which I suppose it stands for make network. Minus sign at topology 3, depth 2, fan out 3. And the syntax here may not be correct. Like for example, when I see topo space 3, depth equal to 2, I think there may not be an equal to. Maybe there is equal to in all places. So I don't know exactly, but something like this you can specify. What topology you want and where you want in the tree, things like that. Useful diagnostic comments like iperf, ping, and other commands in a host. So when you upload when you use a host, already these things are built in. You can ping from one place to the next place, so on and so forth. And you can say in Mininet, for example, H11, your host number 11, if config -a. So this command will be run on host number 11. Okay, ifconfig. ifconfig -a will be run on your host number 11. If you had a real network with 11 hosts, the host number 11, you do that, whatever you will get there, you will get here. So Mininet code for several popular commercial switches are available. So if you want to emulate a switch from Cisco or something, it is there in the Mininet. Okay? All right. Any question about Mininet? Well, the thing is, you will have questions when you have to download it and use it, but I will come to that later on. RESTful API. So we already talked about REST. And REST basically means representation state transfer we talked about right before, but basically it is developed by the architectural style developed by W3C. W3C is the Worldwide Web Consortium, right? The group that developed HTTP, HTML, and other things, right? So they are the one that really get the credit. Introduced by Roy Fielding in his PhD thesis. So Roy Fielding in his PhD thesis introduced the word REST. I don't know whether I would say that he is the, I don't know which came first, the thesis came first or the W3C came first. I think W3C came first. This is my feeling. And so the Web was there, and Web had already designed certain things in its interface, which are representational state transfer. And Roy Fielding came up and said, yeah, this is the right thing to do everywhere. And so he gave the name REST. So the goal is scalability, generality, independence, and intermediate components. So if you want to have a piece of software that is scalable, can be changed, and is general and talks to anybody else, then you put a RESTful API on it. Okay? So the way you access has to be RESTful. And so first of all, the RESTful means client and server styles, and the client and server can be independently developed because the API is defined between the client and the server. If it is RESTful, then they will be happy ever after. Because the server is stateless. That is the key. The key word here in RESTful is, actually it is not even clear when somebody says REST means representational state transfer. I don't think it is clear to me that it means stateless. That's all it means, stateless. Stateless API would be much easier to understand than RESTful API. But anyway, RESTful API, I mean, one way to remember this is RESTful means the server can rest. Okay, server doesn't have to remember anything, and that's what it means. That the server is stateless. You go and ask something, it gives the answer, and next time you are asked something related, then you give the whole context, and that's why they had to invent cookies, because cookie is the state. Otherwise, server will not remember. So you give them a cookie, and then the cookie is stored on the server, which is actually the state. And this cookie is stored on the client, which is the state. And when you want to talk again, then you give the cookies. So responses can be cached for a specified time. And intermediate servers can respond, proxies can respond, endpoint is not critical. So the advantage of RESTful API, which is also the web, is that now you can have proxies. So proxies means something in between which can give you the answer without going to the actual server, because the answer is good for small amount of time. In many cases, the life will come. It will say it's good for 1 second, it is good for 1 day, it is good forever, or it's not good next time. So the proxy will remember that, and if it is not good for next time, it has to go to the original server. So that's the idea of RESTful API. You can create, and there are only 4 commands. There are 4 commands in RESTful. One is create an object, read the object, update the object, and delete the object. This is called CRUD. C-R-U-D. CRUD. Create, read, update, and delete. Okay? Which in HTTP is get, post, put, and delete. Get is read, post is update or insert, put is update clearly, and then delete is delete, right? So read and update. Read is there. Create and update are actually, create and update here are, create would be post, I should say. Insert, instead of insert is like create, right? And put is the write, means basically update. But anyway, those are the 4 commands in web, and there are 4 commands in REST. And the resources are identified by global identifiers. So in the web, for example, we have URI, And we have never used the word URI in the real world, but when the web was designed, we had two different things, URI and URL. Universal Resource Locator and Universal Resource Identifier. Right? For example, my ID would be my social security number. My location currently is in Washington University. So that would be URL. But the URI is somehow that we have never caught on to it. We talked about this ID locator before, right? So URI is how you get to an object, and somewhere that ID has to be located. So for example, you could put HTTP FQDN. FQDN is fully qualified domain name. Fully qualified domain name means all the way up to .com or .edu or whatever to the end. And the last dot we don't put. So .com, .edu, dot. The last dot is not put, but that is the root. And so fully qualified domain name or IP address /rest /version /model /data type /ID. So you can just then say get this or post this or write this. That would be RESTful API. Data types could be controller node, firewall rule, could be a topology configuration, could be a switch, could be a port, could be a link, could be an entry in the flow table. It could be a VLAN. It could be any object, hardware, software, virtual, real, anything. Could be an entry in a table. And for any of these objects, we can create, read, update, and delete. Right? Data types can include commercial entities such as big virtual switch from big switch networks, vCenter from VMware. So the objects, don't have to be just one little idea. It could be a big switch, whole switch. If optional ID and query parameters are omitted, the return text includes all of the items of the given data type. Okay? If you don't narrow it down, if you don't filter something, then it will return the whole thing. So you say, I want to get the object. Then you will get everything about that object. Okay? And I will pick here on Marcio. So let's say I say get Marcio. Now, if I say get Marcio height, then I will get an answer, 6'5" or something like that. Right? But if I say get Marcio, what will I get? I will get height, width, depth, weight, everything, right? So that's the point here, is that if you don't qualify, all the parameters will be returned. Right? So the ID, and then if you qualify, then you get that particular attribute of the object. Any questions about REST and RESTful API? And REST and RESTful are actually synonymous in some sense. And the REST API is, when we say REST API, which is same thing, and RESTful is same thing. And basically all it means is something similar to the web, where there is no state. Okay? And also it also means simple, so that you have just 4 commands and you somehow manage with those 4 commands. Any question? No? Okay. I hope everything is getting through. Otherwise, the next thing is OSGI. So another thing you will notice when you read anything about open source or what is going on in the software-defined networking is that everything is modular. When you have everything modular, then you have to be able to combine them. And that is what this OSGI did. OSGI is the name of an organization whose name is Open Services Gateway Initiative. And I don't know how the name came about, but it is not about gateway anymore. And so it is Open Services Initiative, which means that basically you can take any modules from different places and glue them together. And to glue them together, you need some commands. And those commands are defined by this OSGI framework. The URL is in the bottom somewhere. But basically, So it is a set of specification for dynamic application composition using reusable Java components called bundles. Now, there's a lot of words there. So you have many software pieces, okay, and you combine them, they become bundle. Okay, now you take those bundles and you combine them, and you get some object, right? So there are two levels of composition, right? First, you have little pieces like this, and you combine them, and they become something like that, and then combine these things. And actually, it doesn't have to end that level, but basically, bundles is what you combine. Bundles publish their services with OSGI service registry and can find and use services of the other bundles. Okay, so I'm going to pick on all 5 of you here. Is that all of you could advertise that, okay, I am you're in biomed. What is your specialty? Major?
Biology.
Yeah, I'm a biology major, and I know about biology and networking and this and that. And you say, I'm a networking major, I am this, I'm a PhD student. So everybody can basically advertise their capability, and then whoever needs, if someday I need biology, I go to him. Right? And so that is what the bundles do. They advertise their capability, and who do you advertise to? So that is what this OSGI framework says. No, you don't go and advertise to the world, you just come and put it in the registry. So they have something called registry, a central object, like a central controller, like OF config. You go and tell them what is your capability, and when somebody needs that capability, they'll say, okay, hold on, who are the people from biology here available? See what I mean? So that is what it does. That's all it does. Bundles publish their services with the OSGI service registry and can find and use services of the other modules. Right? So here is a picture. There is a bundle A, and here is a bundle B. Bundle A goes to the registry and says, register me. Right? And service and the bundle B says, get me. So let's say it says, get me bundle A feature. Basically, it will tell you the attributes, and there is nobody with that feature. Then it will say get command, and then it will say listen. So basically, it will listen and wait. Yes, because there is nobody from biology available today, I'm going to sit down and wait until somebody shows up. Right, so that is a listen mode, is that when something appears, then I will be informed, yeah, here it is. Okay, otherwise you just request and wait. And here are some bundles. You can have a bundle for the operating system. On the top of that, you need to run a Java VM. You get an execution environment, you get modules, life cycles, services, and security. So let's see, I think all of these make sense. I suppose everybody understands life cycle. Life cycle simply means, actually life cycle could be called CRUD. We already talked about is that life cycle means bringing a new switch, installing it, updating it, and then throwing it away when it is out of date. Right? That is the life cycle of the switch. From creating to deletion. And so life cycle management and services on the top of the services themselves could be modules and bundles, right? And so each of these pieces, and security is on the side right there. So bundles can be installed, started, stopped, updated, or uninstalled using a life cycle API. So if they have defined a set of commands which you can use to say, I want this module, I want that module, and then combine them and then throw away. Modules define how a bundle can import or export code. Okay, so the modules will define how the bundle can. So there is a way in OSGI to export code. Security layer handles security. Execution environment defines what methods and classes are available in a specific platform, execution environment for the hardware. A bundle can get a service, or it can listen for a service to appear or disappear. So that was the picture on this right side. A bundle can get a service or can listen for a service to appear. Each service has properties that allows others to select among multiple bundles offering the same service. Now, if you say I want a compiler, there are many compilers. Let's say you say I want Python compiler. There are many compilers. So the thing is, you have to select then, okay, no, I want this one. So that is the thing. Services properties that allow you to select among multiple bundles. And services are dynamic. A bundle can decide to withdraw its service. Other bundles should stop using it. So now if I say, so sorry, I'm going to go to sleep, no more, that is done. Right? Basically, so other people cannot use that service anymore. Bundles can be installed and uninstalled on the fly. So that is the OSGI framework. So next time when you see OSGI framework, all it means is that you can dynamically take the modules. If they comply with the OSGI framework, they will understand that they have to register, that they have to respond, they have to be able to serve, they have to be deleted, and so on and so forth. Right? So everything that we talked about so far, the Open Daylight to whatever else we talked about, ONOS and other things, they all use OSGI framework. They all use RESTful API. So RESTful API and OSGI framework are kind of, have become fundamental, and there is no competition to these right now as far as I know. So basically, I thought I will discuss that right here. This is more like a management. Okay, this is nothing specific to SDN, but SDN is following these principles. All right, that brings us to the end of this module. First thing is, SDN initially meant abstraction, programmability, and centralization. Abstraction meant that you will have the hardware abstracted out, then you can do programmability, and you do it from a central place. But all that is gone. Actually, much before that, some people felt that the SDN means open flow. No, not that. Today, SDN simply means disaggregation of software and hardware. And disaggregation simply means that you can choose, you have a choice of hardware and a choice of software, and hopefully they will work together. Hopefully. Because if you take Broadcom ASICs and you take somebody else's drivers, they will not work. So hopefully you will take the right software, right hardware. So bare metal switches plus ONI plus ONL plus routing will give you a software defined network. Actually, what it is going to give you is more like a open network, rather than open network. Anyway, OpenFlow originated the SDN, but now many different southbound and northbound APIs, intermediate services, and tools are being discussed and implemented by the industry. XMPP, PCE, Alto, these are all being used to program. Using XMPP, if you remember, XMPP is the chatting protocol. You can chat to any of the hardware pieces. They will respond to your command. Open Daylight and ONOS are SDN controllers and differ on how much open they are. And Mininet is the network simulation we talked about. And the rest means HTTP-like API. And OSGI is for modularity. Those are the keywords. OSGI is for modularity. If you're going to have pieces from different places, you better have these things, OSGI framework, so that you can ask for them and get them when you need it. Okay? Any questions? Plenty of things on the reading list, Wikipedia, references, acronyms. And I added at the end this new slide. I found it interesting. I was reading Open Daylight, and they had this style guide. which I thought it's good that we all know that how to spell things. Now, let me just go back and show you something. For example, open flow, you don't write open with a little f or open space flow or open flow all lowercase. The correct spelling is capital O, capital F. Okay? And now you go on down the list. NetConf is all capital, Karaf is capital K, Linux is capital L, not all capital X, Linux are all lowercase Linux. Now this is something in your own writing. When you write a paper or something, make sure that you follow these kinds of standards, because that shows that you are educated. All right? Otherwise, anybody on the street will write anything like anything, okay? So, and IPv4, v6, IPsec, R, ACL, RESTConf, RPC, URL. So this is what is the correct way to write it, this is the incorrect way to write it. I found it interesting, so I just put it here. All right. So any final opportunity to talk about SDN before we move on?